In this video, we are going to discuss about examples of some assembly language program. So we know that the program which is operated on the data that will be in the computer memory, right? So the data can be organized in variety of ways, right? So the programmer uses the organization which is called as a data structure to represent the data which is used in the computation, right? So which will include linked list, arrays, queues, and so on. Usually, the programmer written the language in the high-level language. We call it as high-level language. The compiler will translate the high-level language program into a assembly language, right? To implement this constructs using a facility which is provided in the instruction set of the computer in which the program will be run. So the different ways in which the location of an operand is specified in the instruction is called as addressing mode. First, let us discuss about the register addressing mode. Here the operand is nothing but the content of the process registers. The example for this one is move R2, R3. This is an instruction. So here this operand is the content of the process register and the name of the register is given. Right, R2 and R3 are the process register which represent the content of the R2 is moved to the R3. Next one is clear R0, which means I'm going to clear the value of R0. So the next one is direct or absolute mode. So the example for this one is move LOC, R2. So here the operand is nothing but a memory location. That is, the address of this location is given explicitly in the instruction, right? So the location is given. So for example, it is 2000, R2. So it is a address of this location, which is explicitly given the instruction. The next one is immediate node. Here the operand is given explicitly in the instruction. For example, move hash of 300, R2. So here the value of 300 is moved to the R2. This is an example of the immediate view. So here this hash represent the immediate mode. So the next one is indirect mode. Here the effective address of the operand is the content of the register or memory location whose address appear in the instruction. So now we will discuss this two instruction: add open braces, close braces, A, or not. This open braces and close braces represent the indirect mode, right? Next instruction is add R1 open inside this open braces and close braces, or not. So first let us discuss about this first instruction, add A, or not. Here the processor will read the content of the memory location. So this is my memory location. It will read the content of the memory location A. So this is a represent the memory location of A, and the content is B. So first it reads the content of the memory location A. Then it reads the operation using the value B as the address. So now not after this one it will go to B. Okay, B it will take it as a address in order to obtain the operand. Okay, so now this is the the effective address of the operand. Here is the content of the memory location. Okay, so whose addresses appear in the instruction. This is about the first instruction. The second instruction, here the processor uses the value of P, right, which is resides in the register R1. So this is my general purpose register. it will use the value of B, which is in the register R1, as the effective address of the operand. Okay. So first it requires read operation from the memory to read the content of the location B. So this is my general purpose register and this is my main memory. So it will read the so it requires a read operation from the memory to read the content of the location B. So the content of the memory location is nothing but the operand. So this is my effective address. Okay. So after that, what did we do? The value readed is the operand. Okay. So now it is added with the R0. Now it is added with the R0. And the parcel will do the operand effective address, right? It is added with the R0. So this is about the second operation. Second instruction. Now let us consider this is my memory location. Add 10 of R1 comma R2. So this is my index register and this 10 represent offset, right? This is my offset which is a constant value. So if you see in the general purpose register, my R1, it represents some address. Okay, there is a content of the R1. So it is nothing but 1000. So the 1000 represent here the address. Okay, so you go to the 1000 and you add in the 1000 you have some content, right? You have some content and you have to add 10 with this value. So this is my offset, right? So if you add 10 with this value, you will get 1010. So this represent your opera. Okay. And so you can see here this is called as displacement or offset. Okay. So in this instruction, the R1 contains the address of the memory location, that is 1000, and X defines this X defines 10. Here it is nothing but an offset from which the address to the location where the operand is found. So the operand is found at the 1010, right? So in this way you can represent the indexing mode. Another way, you can see add 1010 of R1 comma R2. So here this X represent the memory location. So 1010 and the content of the R1 which is present which is I can take it as 20. So this 20 represent the offset. Okay. So I am going to add 20 with this one. Okay. So 20 with this one since it is an offset. Okay. So there you find an operand at 1030. 1030 you find the operand. This is another way of representing the index address C. So here the offset is nothing but a index register, right? So the 20 here it represents the this is offset, right? This is my offset. Or also it can be an index register. And this is my memory location. So in both way you can represent the this address mode. And the next one is relative address. Relative here, the effective address. So it can be write it as EA. Is determined by the index mode. So index means open basis and close basis, right? Using the program count, right? Using program count. So instead of register, we are using a program counter. So it's just nothing but PC, right? In place of general purpose register R1 or 2 like that. So this is only change. So it can be written as x of PC, right? X of PC. So x plus PC is my effective address, right? So x represent offset, right? So in addition to the 5 basic addressing modes, so far we discussed immediate, register, absolute, direct, indirect, index, and relative mode, right? So in addition to that one, we are going to discuss about auto increment mode. Auto increment mode. So here the effective address of the operand is the content of the register. So content of the register specified in the instruction. So after accessing this operand, the content of the register is automatically incremented. Okay. To the point to the next item on the list. So for example, Ri of Ri plus. So this Ri is nothing but the effective address of the operand, right? After accessing this one, it get incremented. Okay, the content of the register is automatically incremented. So suppose if it is 1 byte instruction, 1 byte means it will increment to 8 bit, right? If it is 2 byte instruction means 2 byte operand means it will increase by 16 bit, right? Because if it is a 4 byte means bytes means that is increased to 32, right? Because 1 byte represents 8 bits. In similar way, I have auto decrement. And this is an additional one. So this is represented by minus of Ri. Okay, here the content of the register is specified in the instruction or first automatically decremented. So here first it will perform this one. It will automatically decremented the content of the register specified in the instruction, and then it is used to calculate the effective address. So first it will automatically decrement the content of the register which is specified in the instruction, and then the content is used to used as a effective address of the hopper. Okay. So these are the two additional modes. Thank you.